The lesson outcome for this video is I can solve systems of equations by substitution, day 2. Okay, so we have already been working on this, and I just want to put a few more examples out here so you keep seeing this and you keep practicing it on your own as well. So first of all, let's remember that anytime you have an x equals or y equals equation already, this one is in standard form, but this one is y equals. That is the equation we're going to want to go ahead and put this little rectangle around what y equals. Remember, we can substitute negative 2x minus 5 in place of the variable y anywhere we see the variable y because they are equivalent. So where do I see a y? Well, I see a y right there. So I'm going to put this negative 2x minus 5 in place of that y. One important thing I want to remind you is when we rewrite this equation now, we're going to do so and we're not going to change anything but the y. That's the only thing we'll change. So I'm still going to write 6x plus 2, and now I'm going to put this negative 2x minus 5 in there, and then equals 2. So again, notice we have 6x plus 2, and then in place of y, we've put what y is equal to, and then equals 2. Now we need to solve the equation on the right. To solve this, we're going to start by using the distributive property. We're going to distribute this positive 2 to both items in the parentheses. When we do so, we leave 6x as it is, and then we're going to multiply positive 2 times negative 2x, which will give us negative 4x. And then we're going to multiply the positive 2 by negative 5, which gives us minus 10, as I write it and say the wrong number. Minus 10 equals 2. Now we'll solve this equation by combining like terms. We have 6x and negative 4x. That's 2x minus 10 equals 2. We will now add 10 to both sides of the equal sign. Pay attention to that equal sign, right? And we get 2x equals 12. And again, divide by 2 on both sides of the equal sign. And x equals 6. Remember, when we're done with a system of equations, it is when we have a solution that is both an x and a y value. So we have to put the 6 right here that we just found for x, and we need to find y. To find y, I highly recommend that we take this equation right here that has the rectangle, the red rectangle around it, and rewrite it right here. And we're going to go ahead and put the 6 that we found over here, we're going to put that in for x. So we get y equals negative 2 times 6 minus 5. So y equals negative 2 times 6 is negative 12 minus 5. So y equals negative 17. There's our solution. Okay, so one more example. This time we do still have an equation that's in x equals or y equals form. This time it's x equals, so be careful that you're always paying attention to what variable that is. So I'm going to put a rectangle around 4y minus 5, and I know that I can put that anywhere I see an x, which is right there. I'm going to rewrite this equation exactly how it looks. So 3, but instead of an x, we're going to put 4y minus 5, and then minus 2y equals 5. We're going to distribute the 3, so we get 12y minus 15 when we distribute, and minus 2y equals 5. Combining our like terms of 12y and negative 2y, we get 10y minus 15 equals 5. We're going to add 15 to both sides of the equal sign. Add 15. And we get 10y equals 20. We'll now divide both sides by 10. And y equals 2. This time, be careful. We want to put that 2 right here. It is the y value. And now we're going to take this equation right here, and we're going to go ahead and rewrite it. X equals 4 times y minus 5. So x equals 4 times our 2 over here for y minus 5. So x equals 8 minus 5, x equals 3. And there's our solution to this system.